Morning. Today we are going to look at probability distribution. A probability distribution gives the probability of each possible value of the variable. If you've got different variables and they have got different probabilities, we can represent those different probabilities by way of what are called probability distributions. Right? We are going to look at an example of how you can represent these probability distributions on a probability distribution table. Right? So first of all, let's write what probability distributions are. So we said gives the probability of each possible value of the variable. Right? For example, if we have fuses that are in a box and you are told that some of the fuses are faulty and some are not faulty, and then we are given the probability of picking a faulty fuse, the probability of picking a fuse that is not faulty, right? Then we now need to calculate or represent the distributions of, say, probability of picking zero faulty fuse, the probability of picking one faulty fuse, the probability of picking two faulty fuses, and so on, in a bag containing fuses, and we are told that the probability of a fuse being faulty is, say, 0.2, meaning that the probability of a fuse not being faulty would be 1 minus 0.2. So let's put this one, this information here. Suppose we have okay, three faulty fuses are put in a box containing two good fuses. Right, what is the probability that we take a no faulty fuse, B, one faulty fuse, C, two faulty fuses. Right, so the three faulty fuses are put in a box containing two good ones. So here in this example here, the total number of fuses here altogether are 5. We have 5 fuses, and the probability the probability of getting a fuse that is faulty is 3 over 5. Right? So we can draw a tree diagram here where we are saying this is faulty, this is not faulty. The probability of getting a faulty fuse is 3 over 5. Alright, because there are 3 faulty fuses. And then the probability of getting a fuse that is not faulty is 2 over 5. Alright? Now, if you take 2 fuses from the box, right? You take 2 fuses. You take 2 fuses from the box. Alright? You take 2 fuses from the box, and then you want to find the probability that the fuse that you take in the fuses, on those 2 that you take, there will be no faulty fuse. So this is the first pick. The second pick is this one here, where we now have, because we've taken 1, we now have 4 fuses left on the second pick. And if you have taken a faulty fuse, it means now if a faulty fuse has been taken, it means there are 2 left. So we have 2. The probability of taking another faulty fuse will be 2 over 4. And the probability of taking a fuse that will not be faulty out of the 2 there will also be 2 over 4. And here, if you take a fuse that is not faulty, right, we are left with 1. The probability of taking another faulty fuse will be 1 because you've taken another one. And then the probability of taking a fuse that is not faulty after taking a fuse that is not faulty, the probability of taking another fuse that is not faulty is also 1 over 4 there. Right? Then our probability now for taking, here is taking a faulty followed by another faulty. Here we are taking a faulty followed by one that is not faulty. Faulty, not faulty, followed by faulty. Not faulty, followed by not faulty. Alright? Now, these probabilities will be, here it will be 3 over 5 times 2 over 4. There is 3. This one is, okay. Wait, why do I use this one? 4, okay, it's fine. Faulty followed by not faulty. That's 3 over 5 times 2 over 4. And then not faulty is 2 over 5 multiplied by 1 over 4. Alright? Getting both not faulty is 2 over 5 multiplied by 1. 1 over 4. Right. This is the probability of getting from picking 2. If you pick 2 fuses and you have them in your hand, the probability of having both of them faulty is 3 over 5 multiplied by 2 over 4. The probability of us having a faulty and a not faulty fuse are these ones, these 2 here. Right? Whereby you can pick a faulty fuse first, followed by a fuse that is not faulty, or you have another option where you pick a faulty fuse, a fuse that is not faulty, followed by a fuse that is faulty. And so, so the question says no faulty fuses. The probability of picking no faulty fuses, it's P F1 no faulty, right? Which is 2/5 times 1/4, right? That gives you probability no faulty fuse, which is equal to 2/20, which is equal to 1/10. And then the probability of picking one faulty fuse, P, one faulty fuse, is equal to this one here, F1, you pick plus, F, not faulty, faulty. Faulty, you can pick a faulty fuse and a not faulty fuse, or a good fuse, or, that's why I have a plus there, a fuse that is not faulty followed by a good fuse, which gives you this here. The first one is 3/5 times 2/4 plus the second one, that branch of the tree, which is with 2/5 times 1/4. Alright? This gives you 6/20. Oh, sorry, yeah. This is a 3/4 there. Right, because we had we picked we had 3 faulty ones and we picked a good one, so this one becomes 3/4. So here we have our 3/4 there. Right. This gives us 6/20, which is 3/10, plus 3/10, which is equal to 6/10, which is equal to 0.6. Right? That is equal to 0.6. And then the probability of picking 2 faulty fuses is faulty. P 2 faulty is equal to which is equal to 3/5 times 2/4, which is equal to 6/20, which is equal to 0.3. Right. Now, let me draw this table more neatly. Well, this is my tree diagram. 40. Here we have 3/5, 2/5. Then after picking 140, we now remain with 240 and 4 of them. And here, after picking a 40, probability of picking something not 40, we have 2 already, 2 not 40 inside the bag. And then right, this is our tree diagram. Here we have, this is picking a 40 followed by another 40. Right? Probability picking a 40 followed by a good one. Probability picking a good one followed by a faulty. Here we have probability of picking 2 good ones. Alright? Now these probabilities, this one here is equal to, as you say, is equal to 3/5 times 2/4. This one is equal to 3/5 times 2/4. Here, 2/5 times 3/4. 2/5 times 1/4. Right? If you put these ones to decimal, this is equal to 0.3, 0.3, 0.3, 0.1. Right. That's what we have on our tree diagram. And then we can say this is 0 faulty. This is the probability of picking all good ones. This is 0.1. Probability of picking one faulty. Probability of picking one fault is given by that. We have 0.3 and 0.3, which we add now to get 0.6. And then this is probability of picking 2 faults. Right? That answers our question. The question said probability of picking no fault fuses. The probability of picking no fault fuses is 0.1. Right? The probability of picking one fault fuse 0.6, and the probability of picking 2 fault fuses is 0.3. Now we need to now draw our probability distribution table. Right? Which we draw like this. Our variable x when our variable x is 0, what is the probability? When our variable x is 1, what is the probability? And when it is 2, what is the probability? So the probability of x, the small x is our Now, from our table, we had 0.1 here as the probability of picking all good fuses, no faults. And then 0.6 for picking one faulty fuse. And the probability for picking two faulty fuses, we got it as 0.3. Right? So for your distribution, probability distribution, you first calculate the probabilities, right? Of this. These are the discrete variables. We can take whole number values for X, like 1 fuse, 2 fuses, 3 fuses, and so on. And then the number of pickings, how many, the number of, if picking zero faulty will be given, the probability will be 0.1. We calculated this using our tree diagram. And then from our tree diagram, we extract that information and then put it on a probability distribution table. You can also represent this on a graph, right? A vertical line graph, where we are now saying this is our value of X, taking values from 0 to 2. Here we can start by putting we put our 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. This is our maximum value, 0.6. This is our P. X is equal to X. This is our X value. Then for distribution, for probability of, if X takes a value of 0, the probability is 0.1. So your vertical line bar will go up to 0.1 there. If the value of X is 1, the bar goes up to there. That is the bar. And then the bar for X is equal to 2 would be like that. Alright? So this is our X, and that one is P. X is equal to X. Now we can now sum up the probabilities. P X is equal to 0 plus P X is equal to 1 plus P X is equal to 2. Can sum these ones up and they should give us 1. Right? They should give us 1. This is X is equal to 0 give us 0.1 plus 0.6 for X is equal to 1 plus 0.3. This should give us 1.0. Gives us 1.0. So for a discrete random variable, the sum of probabilities is 1. Right? The function that we use to allocate the probabilities, this function P X is equal to X, is known as the probability density function. Right? Probability density function. P X is equal to X is the probability density function of X. It is the probability density function of X. Right? We are going to look at further examples next time. This lesson here just introduces the concept of probability distribution. How you can calculate them using a tree diagram, and then you now put them on a table. You can also represent them on a vertical line graph. And you also need to remember that if you sum up the probabilities for each variable, sum them up, all of them. If you sum them up, they are supposed to give you 1.